Hello, everyone. My name is Sergii Sushko. Me and Alexander Chemeris, my colleague, would like to introduce our paper, Energy Efficient Computing by Using of Software Optimization Aimed on Execution Time. As you can see, it's related to software optimization in context of energy efficiency. As you can see on the picture, energy efficient computing is required to reduce resources. This is less electric usage, less heating, and less operational costs. If to review dissipations of electric power in integrated circuits, we can find that it has several subparts. Static power is in every time of working. It does not relate it to everything, but dynamic power is used on only with switching of circuits. It means that without any switching, it will be zero. What is the relation between software and hardware, especially of electric power consumption? As you can see, if we have some software code, it will be compiled or produced to any another way for central processing unit. After it, then it will be executed by CPU. It will switch some electric gates, which, as we saw before, will produce electric power, which require electric power and produce power dissipation. It will require some cooling system. What can be told about software optimization? In common, software optimization can be divided on three big domains of optimization itself. It's different sides of optimization. They can add to each other and improve each other also. So this is algorithm optimization, which is related only on high-level algorithm. Macrocode optimization, it's how algorithm is performed by commands of CPU. And microcode optimization, it's how CPU commands are compiled to executional code. Our task is related only to macrocode optimization, which means that we don't change algorithm itself or made some CPU improvements. We just change our code and try to find better solution. Actually, there are a lot of methods of optimization. One part of it is methods of optimization of computational loops. And it's used only while a code is related many times. As you can see, there are a lot of them, but it's not everything. And some of methods like parallelization and tiling are highlighted. Parallelization, this is a computational, it's an optimization and computation are split it onto several processors. And tiling, this is another method. It's a little bit harder to understand, but if we will see on the picture right now, we can see that it has, if we have computational loop with two axes, but it can be 3, 4, 5 dimensional, it doesn't matter. This is just an example. And the tiling method is an idea to divide it by smaller blocks. Actually, this is our tiles. And compute it with lesser increment of iterations. Also, such blocks can be divided on several processors, and it also boosts speed of the computation. So what what we have here, this is Pluto software. Actually, this is a special tool which allows us to use different optimization methods in automated way. So we put some code on it. It will do all the job, and at the end of it, we will have another source code which can be used and compiled as regular code. So here we can see some parts of Pluto software. This is actually a framework which requires another parts to work properly. So just to let you know how it works, let's have a look on it. So from left side, we can see how regular software is used. So we have some source code, we have some compilation, and we make program execution on which we can measure execution time. While in optimization, we have another thing to do. This is source code transformation. So after original code, we have some optimized code, and then we do again some compilation and program execution. On which stage we also can measure execution time. So what we've done to discover it, we took Raspberry Pi. We took Raspberry Pi board, which is a single chip architecture. This is ARM architecture, and it's quite small, but has a lot of ports, a lot of possibilities to make some computation, IoT, domestic usage, file server, and so on, so on. It's powered only with power supply, which can be USB. So this is quite low power device, but for some cases, this is enough to use. Also, it has some GPIO pins. It can be attached to some external device like sensors, cameras, whatever. So we discovered that board. And what is the methodology? So if we would like to measure time of everything, of execution time, we know what to do. We need to measure before and after. What we need to do to measure energy efficiency. So we introduce the coefficient, which is on the bottom top of the page. But we obtained it as follow on the picture. So we have some energy, we have some power, and actually this is a division of energy before and after. If voltage is the same, so it can be eliminated, and we have actually multiplying of two relations of execution time and current consumption. So actually what we need to do to compute energy efficiency is just to find out these values. So actually, as you can see, it's just 3 steps to do it. First 2 are measurement of execution time and average current consumption. Actually, this method is also good for another boards. So if for example, if we use big PC, which uses some power from electric grid, and we have some instrumental and tools to measure power, not current. So actually, it's also related to it. We need to measure power and use the same formula. And final stage, it's computing of energy efficient coefficients, as we saw before on the formula. So when we done it, we obtained such formula, such plot. On the plot, you can see different values for different optimization methods, which is mentioned on the top of it. horizontal line is different test programs which we used. It's about 25 of them. And vertical X is actually energy efficiency coefficient. How to treat it? If it equals to 1, it means that nothing happens and energy efficiency is the same. So if it's bigger, it's better. If it's lower, it's worse. So as you can see, it's very different on different softwares. In top case, it can be up to 5, but regularly is 2 or 3. Also a lot of tests which is around 1, so it's no significant energy efficiency improvement. But for some case, we can see that it can be only half of it for one test. So it means that no energy efficiency was achieved and everything went even worse. So also in common, it means that not every optimization software can lead to energy efficiency. And it should be discovered in particular in every time. And also, it's a good idea to check particular optimization methods, also in particular software. So just to conclude everything, why it happens, we can see that in some cases, execution time reduces, even for a single thread. And another factor is that even power consumption is increasing for multi-thread usage, but speed up is even better. So in that case, energy efficiency will be better than before. And also some particular optimization cannot give speed up and also will not give us any energy efficiency. So thank you very much. And please give me some question for you.